Okay. Good afternoon, everyone. Sorry about the delay. My name is Pedro Piñeiro. I will be the session chair of the first remote paper session of the conference. Okay, we have a little change in the order of the presentations. We are going to start by the second talk, titled Ensemble Learning Models Applied in Energy Time Series of a University Building by Isaac Ortiz-Aguirre, Michael Espinoza-Andaluz, and Julio Barzola-Monteses. Okay, thank you.
Thank you. Good afternoon, everyone. It's a pleasure to be here with you today in virtual mode. First, I like to introduce myself. I am Julio Barzola from University of Guayaquil. I am lecturer professor. My presentation this afternoon will concern primarily ensemble learning models applied in energy time series of a university building. This outline, to begin with, I'll be speaking about energy in the building and conclusion sector. Then I'll describe ensemble learning model used in forecasting problem. After that, I explain the results obtained of the testing. And finally, I'll give conclusion on this work. Globally, building energy consumption represents a dominant factor in the transition to clean energy. The International Energy Agency report show growing trend in energy consumption and carbon emission relate to the fuel used in the building construction sector. In 2020, the construction and operation of buildings globally account 13% of final energy use, and carbon emission was about 37% of the same years. In the Ecuadorian context, according to the 2020 National Energy Balance, the national consumption in residential, commercial, service, and public administration building was approximately 22.1% of the total consumption in Ecuadorian case. The primary source of energy used by building was electricity, representing 15.8%. The energy demand in the country increased 14 to 3% between 2010 and 2020. Despite the pandemic, the upward trend has continued in the last 10 years, especially in the year 2020, where there was greater consumption in the residential level due to, for example, teleworking. Energy efficiency in building can be addressed from the following approach. White box approach based on the physical models, black box approach based on the machine learning tools, and green box is a combination of the physical and data-driven prediction models. Machine learning models operate as black box and need no information of building system. They discover the relation between various input features and output targets using given data. In this study, we use machine learning technique using supervised learning. We have considered as a reference a scheme developed in energy efficiency project in a hotel in Europe, the project in Europe, but in our case, we focus on exploring machine learning technique to predict energy consumption of the university building. This resource will be used as input for energy optimization models in the building. For example, optimizing the set point of HVAC system. Okay. About Ensemble leader models, we use on the decision tree. DT is made up of the series of the if-else rules in the regressor that affect the predictor variables. To predict an answer, the user must follow the decision of the tree for the root node to the leaf node. This last node contains the repose. Ensemble linear DT optimal and potentially convincing predictive models. Okay, this work considers the two most popular bootstrap aggregation and boosting ensemble leaders. About bootstrap aggregation bagging ensemble learning, we use under random forest. Bagging is a method that searches for a different group of ensemble members by varying the training data, training each model, that is, training each model of the different sample from the same training data set. Another model is the boosting. Boosting is another ensemble leader approach to improve the performance of the decision tree. Boosting works similar to bagging, except that trees are grown sequentially. Each tree is produced using information from previously grown trees. Okay? About the experiment evaluation and discussion, object of the study this building. Okay, before pandemic, building will in the 16th. You can see the peak electric load is about 152 kilowatts, and electrical consumption represent $110 only 1 day. Okay, is very this building represents of the 5% of the consumption of the University Guayaquil. Okay, the data set contain the measurements of the resolution of the 15 minutes during the period from the February to November 2021. The total active power curve is the variable of the considered for the analysis, and data set is considered of 80% for black color to train data set, and blue color for 20% for test data set. About the problem framing, is here, given the history of energy consumption of the building, university building, what is the expected energy consumption of the for a step ahead? Okay. On the other hand, we can see the table 1 hyperparameter we use for decision tree, random forest, and ESG boosting. Okay. About the model performance evaluation, Before cross-validation does not work for time series data, as is known. Therefore, the rolling forecast scenario will be used, also called walk-forward model validation. Models are implemented use scale time, okay? On the other hand, for the metric performance, we use the root mean square error has the main metric to select the best architecture with the lowest forecast error. Other supporting metrics are mean absolute error and mean absolute percentage error. This slide shows the result achieved with the decision tree model. We can see that there is no suitable generalization between the predict versus expect dataset. Okay. This slide shows the results achieved with the random forest models. We can see that there is a better generalization between the predict and expect dataset. Okay. Finally, this slide shows of the results achieved with the HG boost. We can see that there is also a better generalization between the predict and expect data. Okay. About general comparison between models, we can see table 2 and table 3. In table 2, they are common in hyperparameters such as estimator, max depth, window length, and computational times. We can see the relation between the complexity of the model, of the architecture, and computational times. Okay? On the other hand, on the table 3, show the mean error metric in forecast during model validation, assemble linear models, random forest and XGBoost outperforms of decision tree model. Okay. But the random forest is the better. And additional, multilayer perceptron is used for contrast these results. And random forest model is very close in forecast error compare of the multilayer perceptron. Okay. Conclusion. In this study, machine learning models were applied to forecast the energy consumption of the university building. Experiments were conducted using a univariate time series dataset of the total active power from the university building. Three techniques of machine learning were considered, and models were configured, training and validate. Metric performance were used to select of the best model of the each type of architecture. Assembly learning models achieve the best forecast results. In particular, the random forest models obtain the best performance results in the work and were very close to the deep learning multilayer perceptron model. On the other hand, considering the free machine learning models, the best computational time was achieved with the decision tree model, no? Because the complexity architecture is more sample. This model can be used the reference in predictive control system, applying homes and buildings since they can predict energy consumption in the short term with outstanding precision. Future study, we intend to use random forest model considering multivariate time series, other range of the other range of the values of the hyperparameters. In addition, control forecast error metrics with other techniques such as artificial neural network, among others. Okay. Thank you very much for your attention. This is my presentation.
Okay, Julio, thank you very much for your presentation.
Any question? Thank you.
Any question? Okay, Julio, this study you can translate to other type of buildings? Is applicable to other type of building? What do you think?
Yes, it's applicable. Data is real of the building. The scope of the lecture is to have the forecast precision for the next study and these optimizing models. Okay, these are the belong of the project of University of Guayaquil.
Okay, thank you, Julio. Another question? No? Thank you, Julio.
Okay, thank you.
Okay, we continue with the presentations. We have now the third talk titled Evaluation of Multi-Objective Evolutionary Algorithms for the Design of Resilient OTN over DWDM Networks by Arison Oliveira, José Cleyton Silva, Danilo Araújo, Joaquín Martins Filho, and Carmelo Bastos Filho. Okay, Arison, you are the presenter. Hello, Arison, you can start.
Hello. Yeah. Okay. Hello, everybody. Good afternoon. It's a pleasure to be here. I'm Arison, as you said before, and I'm from University of Pernambuco, Brazil. And it's a pleasure to be here. I present my paper called Evaluation of Multi-Objective Evolutionary Algorithms for the design of resilient OTN over the DWDM networks. So it's the topics that we discuss later. So first of all, it's known that the demand for telecommunication services has been growing due to the increase of the number of the applications in the internet. Applications like social media, video stream, and so on. Thus, the most suitable technology to supply high transmission rates is optical networks because they can reach high transmission rates at relatively low costs. And one standard that can be used in this case is the optical transport networks that were proposed to better manage this system's operation because it allows the more efficient use of the resource of the optical layer, and it also brings some economic and operational benefits. And when we are planning networks, there are some difficulties And depending of the size of the network, concerning the number of nodes and links, the planning process can be pretty expensive, and it can be it is costly. It's a costly process in computational terms. So the computational time can exceed acceptable levels. In this case, the solution is the use of some meta risks. And we know that there is a range of multi-objective optimization algorithms, and some studies are already carried out. The first study is a physical network layer based on socioeconomic data, which used some evolutionary algorithm for planning the physical network and based on socioeconomic data. And recent study used the NSGA2 to plan OTN resilient optical networks over the DWDM. But we know that NSGA2 it's an older algorithm, so this paper aims to analyze the performance of different multi-objective algorithms for the design of OTN and resilient optical networks over the WDM. So the optical transport network, or OTN, introduces a new set of equipment and logical structures that is called line cards. And the line card can have the throughput going from 10 gigabytes per second until 400 gigabit per second. These line cards performs which is called optical transport switch, as in showing the figure beside. And when we planning the network with this kind of this structure, we need to attend to three another points. The first is the OTN node, that is the logical representation of the OTN switch and is associated with an optical layer node, as is shown in the black here. Another structure is the link bundle, is the T-link, that is the connection between the two interfaces, and a link bundle is the end, which is a set of the T-links and between two OTN switches. When we choose some meta risks, we can divide into three groups. The first is the classics, and the NSGA2 and SPEA2, swarm-based SMPSO and OMPSO, and some of them promising on real-world problems like HYPE and MO cell. About the planning tool, we developed a planning tool to help and simulate the design of resilient optical networks, and it was done using Python. This planning tool can be divided into three steps or phases. The first one is initialization, after the allocation, and at end the fault analyzer. The initialization doing simply reads the CSV files, and in this CSV file contains the network topologies and the services demand. After that is performed an allocation, which allocates, as the name suggests, the demands in the network according of the criterion on the protection and restoration. The criterion, all the criterion can be shown here, 1 plus 0 until 1 plus 1 plus R. And the last step is the fault analyzer, which simulates some single or double faults. And when the faults occur and it's needed to be restored, is done a restoration process, and at end is realized the RF calculation, and RF stands for rate of unsuccessful failure of recovery, with a ratio between the unsuccessful recovery over total historic attempts. That will be explained further. And in our simulation setup, we choose two topologies network, one simple with only 4 nodes and 7 link bundles, as shown in the image here, and another complex, more complex network with 16 nodes and 32 link bundles. The services to be allocated is shown in this table. The two topology one only 80 services, and with the most very type of the services, and for topology 2 was used 240 services, which types only 1 plus R, and here we can see the origin and the destination from these services. About the matrix setup, the individual was modeling like in this image here, in which each gene here represents one tail link, but each gene has one tail link, but we need to remember that for each link bundle need to use two interfaces, like it shown here, and when we are evaluation, we are considering two parameters. The first one is the number of interface, which is just sum. This is parameters, and the RURF parameter, which means how much this network is resilient to faults. And the configuration of the multi-objective algorithms we set like it's shown here. The population initialization is random, so at each initialization a new population is generated. The population size for topology 1 is 20 individuals, and to topology 2, 30 individuals were considered. For mutation, we used polynomial operator with 5% mutation rate. Only for OML PSO, the uniform mutation was used with the same rate. To crossover, SBX operator was used with ratio of 30%, and as criterion stop criterion was using 10,000 iteration for topology 1 and 50,000 for iteration, for topology 2. And about the results, first of all, we can note here a graph, hypervolume per iteration. So we can note that in this point here, in almost 2,000 iteration, the OML PSO and in SM PSO have stagnant, and the hypervolume have a stagnant hypervolume from this point. And at the end of the iterations, here at 10,000 iterations, all the algorithms converge. So when we can compare here the Pareto front, and we can notice that almost the same that all algorithms have almost the same point in the Pareto front, and because of this, the spacing and the maximum spread was the same value to all algorithms. To topology 2, we can notice here the comparison between hypervolume and iteration. We can notice that in this graph here, in almost 20,000 iterations, the hyper algorithm has the biggest and the stable hypervolume, and in the Pareto front here, we can note that it can be provided, sorry, because the points here it's almost it's closer to the origin. And another result to topology 2 is is here when you can notice that the minimum number of interfaces it's the hype obtained the had the at least sorry the hype had the last number of interface and was the third fastest in the execution time. So what about the conclusions? In our work analyze the performance of different metrics in the design of resilient OTN over the DWDM optical networks, and it was possible to observe, to notice that different network topologies can use different metrics and can be more effective. So in our case, for topology 1, OML PSO and SM PSO are more effective because they have the better solution with 17% less iteration and a shorter execution time. And for topology 2, the hype was the most effective despite being computationally costly because it was found the less amount of interface. So thank you so much to watch, and I'm open to answer your questions.
Okay, Edison, thank you very much for your presentation. Do you have any questions? Okay. No, the
Thank you, Alison, for your presentation. I have one question. In your position, you didn't indicate what routing algorithm and what the assignment was applied in the simulation. Can you explain that?
To be honest, I can't understand better your question because it has some echo in the, I think, in the auditorium. If you can repeat.
For each request, you need to calculate the route from source to destination. For this route, you need to indicate what wavelength is used. Can you explain the routing and wavelength assignment problem? What algorithm was used to solve this?
To be honest, the sound here is not so good. I think that if the master, the person which is present in the LA-CCI could repeat because I couldn't understand, to be honest, because of the sound in my
perhaps you can
transmission.
show the slide.
Yeah, I can hear you better.
Show the slide.
Yeah, I understand you better.
You can show it.
I understand better the presenter, but the person which did the question, I didn't understand.
Can you show the slide? The slide of your presentation? Repeat the slides. Then you can perhaps understand the question.
Okay, which is the slide? In the results?
Isn't the results? No?
So when you define the number of links between two nodes, this is the neural design that was codified in your chromosome. I understand that part. But what happened we get request. How a request is routed in this designer network? This is the routing and wobbling problem inside of the network design problem. It was considered, or the routing and wobbling problem was solved in your simulation. Is implicit this problem in your simulation?
You understand, Harrison? No?
No, the sound of the microphone of the presenter, the person which is doing the question, I can't understand. But I can share my mail after. I think that you can talk with me after, and I can answer your question. I don't know if it works with you, but I can answer you after. Could be?
Okay, thanks for the question. Actually, I am one of the authors of the paper. And actually, this is a part of a big project we carried out with a company from Brazil called Patec. And within the big project, we have tested and assessed different routing algorithms. And for this special case, we have static traffic. So we do not have the dynamic routing during the process. But what we do for the routing process is we have assessed different routing algorithms, and then we selected one of them that uses the best distribution of load along the network. So this is what we call the distribution load, minimizing the how can I say, the deviation of this distribution load along the network. It doesn't matter a lot for this small scenario, but when we test in networks with a large number of nodes, it has a huge influence on the performance of the algorithms.
Okay, thank you
so much.
Harrison, I have also a little question. Why do you select these typologies for your numerical experimentation? Do you consider another?
Yeah, we consider a previous work, this work here, and because as I said, this work only used NSGA2, and we could compare with the same scenario and obtain different results. So it was the same topologies in the same scenarios with the same services and so on,
Okay. Thank you. To complement this.
Actually, what we did for this paper was to use some regular topologies, so just to assess what is happening in the network. But actually, we also deploy this kind of methodology for real-world topologies, but we cannot show for because we have this NDAs with the company, and because of this, we cannot show the information that regards on the information for of the company. Okay.
Thank you. Okay, any other question? Okay, thank you, Harrison. Okay, we finish with the session because we have not the first talk. Okay, thank you everyone for coming to the session. Okay, we end. No? Thank you.
So good afternoon. It's my pleasure to present the next invited speaker, Rosangela Ballini. She's going to present the adaptive fuzzy system in economics and finance. It's related to some of the talks that we have today. I just would like to say that she has a bachelor in mathematics with a master's in computational mathematics and a doctorate PhD in electrical engineering, but now she is a professor at the State University of Campinas. So I hope you all enjoy the talk. Thanks a lot for accepting the invitation, and feel free, the stage is yours.
Thank you. Hello, good afternoon. Thank you for introducing me, and thank you for inviting me for this conference. It's a pleasure to show some subjects that I studied during some years or the last years. And today I specify the subject about the fuzzy systems again, because yesterday I presented the similar subject. And here I apply the fuzzy rule-based systems in economics and finance series, time series. Here my goal, okay, is time series forecasting, okay, and I evaluating interval forecasting, not a single value, but interval forecast of the high frequency state. And here, okay. First, I will present the motivation about this subject, and I will present some literature about this subject, interval value series. And to try this time series, we needed to show some interval arithmetic because it's needed to use the interval arithmetic. And finally, I go to the model, the interval fuzzy rule-based model. This model is composed in two parts. We have the first part is fuzzy clustering, and participatory learning and the fuzzy semins, both of interval participatory learning and interval fuzzy semins. After the second part of this model, we have the estimation of the parameters of consequence, and I discussed the results using, like the literature, used for estimation of the parameters of consequence, because this is a point that I think we needed to advance in this point for estimation. And I showed the two applications, stock market and exchange rate. And of course, I finished indicates future research for me, or I hope for us. First, I start to show the interval value index Ibovespa. Here we have two series. The red indicates the height, and the blue low indices. And in this figure, you show the movement around of the series, but we have some complementary information, because each day we have the variability of the series between the high and low values. And of course, the most methods estimate the single values and not the interval values, because when I look at this series, I have the interest to single values, but if I have the intraday variability, it's really important for the investors, for example. Then, when accurate prediction to stock markets or exchange rates is really important in international trade, risk analysis, portfolio selection, derivatives pricing, making decisions, investors. And the most traditional time series forecast methods is specific single value variables, and these models don't consider the intraday variability. This is a question, because it's really difficult to preview the single values. And the interest of the investors is the variability, the volatility values. It's not the single value values. And when I look at the heights and the lowest values of price, I have the interval time series. Then, the high and low prices are reference values for investors, and these values are related to the concept of volatility or variance. When I talk about variance, I talk about precision. If I need the good precision, I need to try interval values, okay? And the interval value data have been considered in the field of symbolic data analysis. Now, This field is related to multivariate analysis, pattern recognition, and artificial intelligence. This is the subject that I try here. And the interval valid methods have shown superiority of univariate and multivariate statistical methods. I think it's better than. And here I show some literature about this subject, and I indicated some advances in each one. We have different approaches. The first, Billiard and the Day 2000 have proposed a regression analysis for interval valid data. Here, the authors show the computer of regression analysis using the mid-data and half range interval data. Or that is, we have the interval, but I computed the mid-data and the range, and I transformed the interval in a single data, and I computed and I obtained the regression analysis using this single data and return the interval again. The second one, Lauro and Palumbo, introduced the principal component analysis methods for interval data. Here, the authors proposed to identify the principal characteristics of the data. De Carvalho, 2007, from Pernambuco, okay, Francisco, have considered a fuzzy means clustering methods using interval data. This is, I think this is a really important algorithm because the authors proposed try interval data and not mid-data or range data. Here, they consider fuzzy means clustering methods for interval data. Here, the last one is my colleague, Maciel, Fernando Gomes, Jäger, and me. We introduced the participatory learning. Participatory learning was introduced by Jäger, and here we extend this idea for interval data. Well, the literature advancing in other, but in traditional statistical techniques like vector error correction model. In this case, the authors consider each series independently. Not the interval data is the input, but we have the input, the low, and I have the input, the high data, and I estimate the model, and we have the prediction. The vector error correction model, the authors use it because they propose this series have the co-integration and the same movement during the time, and they try this using this model. Maya et al. In 2008, again, De Carvalho and Ludmila, Teresa, discussed the, no. This is Maya and De Carvalho, 2008. They proposed the autoregressive integrated moving average model for times interval data. Here, again, the idea of midpoint and the range, half range, is used in this case. Arroyo et al., I don't remember all the authors, use the interval exponential smoothing methods. Okay? More recently, maybe, we have Rock et al. Proposed an interval multilayer perception. And here, in this structure, the weights are interval. That is, we have the inputs. The inputs are interval, the output is interval, and the weights are interval. That is, all the model is interval model. This is really interesting because when I transformed the mid data and the range data, I lost the information. Okay, and the Maya, here, Maya, De Carvalho, and Ludmilla proposed a method that combination the ARIMA and the artificial neural network using mid data and the range data, and the range of the interval data. Finally, Xiong et al. Introduced the multi-output support vector regression, and in 2017, Maciel and Ballini proposed a fuzzy rule-based model. All the application and the development that I show here, I have the contribution of Maciel, Fernando Gomes, and Jäger for application and the development of the model. Okay, interval arithmetic. When I have the interval value data, we have the XL and XH for each data, and the data is a closed bound set of real numbers. And if I have the time series, interval value time series, I have collected in a chronological sequence because here I have time series, okay? And then for each time I have the interval, okay? And here we show some interval arithmetic, the midpoint. I need this. I show the results using midpoint, using half range, and I use during the algorithm use interval arithmetic suggested by Moore, like addition, subtractive, product, and divide. And here, of course, when I need the compute the first part of the model, the clustering, we need the distance. And here I show 3 measures. And we have the Euclidean distance, Hausdorff distance, and Zipf-Bloch distance. I show IPL, or interval participatory learning, using Hausdorff distance, and here I show the interval for the means using Zipf-Bloch distance. Okay. But there are other results using Euclidean distance. The difference between the results is not really significant digitally. Okay. Well, the model. The model will have a fuzzy functional rules. When I have if the consequence, then we have the antecedents, we have the consequence. Okay? If antecedents, then consequence. Each input is the interval data, and the output also. And here, I represents the fuzzy set of the antecedents. In this model is based on Takagi-Sugen type, where the model uses parameterized fuzzy regions and associate each region in a local model. Here, this is represent for computing the output of the rule is a local model. And the non-linear network of the rule-based model emerges from the fuzzy weight combination of the collection of the multiply local models. And the output of the model, we combined the local models using the membership degree. Okay? And the contribution of the local model to the model output is proportional to its degrees of activation. Here, I show where I computed the output of the model. This is the combination of the output of the local model. And here I have the two parts. The modeling requires learning of the antecedent part of the model using interval fuzzy clustering algorithm, and we need the estimate of the parameters of the consequence. All computations in this model is using interval value data, but I show some results using midpoint and range, half range intervals. Okay. Antecedent identification, like I showed you, I used first participatory learning fuzzy clustering for interval value data introduced by Maciel, and fuzzy semins clustering algorithm for interval value data proposed in 2018, 2019. And I computed the consequent parameters. First, I show the results using mid and half range of the intervals, like Maya in 2008. And I used the other approach that I preview the interval using the min-max approach suggested by Bida. Well, the first participatory learning, the first clustering, I applied in Brazilian stock market, and I compared the results using univariate and multivariate models. Participatory learning, the goals of participatory learning is already now in the learning process. New information contributes to learning. We needed to compute the the distance between the input to prototypes or center of the cluster. And here in this proposed, when I transform the participatory learning to interval participatory learning, for each cluster structure are defined by cluster center represented by interval also, okay? The goal to learn the value of the centers, and for the learning during a sequence of observations are presented for the model sequentially, okay? Participatory learning principle to be relevant for the learning process. XT must be close to VIT. The prototypes are updated using this form, where it's based on smoothing equation. Here we have the distance between the inputs and the center, cluster center. And we needed to compute the compatibility, like here. And we use the Hausdorff distance to compute the distance between the input to the cluster center. Okay. Well, interval participatory learning consider another not parameter, another thing is arousal mechanism to account for situation when conflicting observation arises. When higher arousal indicates less confident is the system with the current belief, and that is a new cluster is created in this case, and the arousal is updated following this. And if the arousal index is greater than the parameter lambda, a new cluster is created. Otherwise, its most compatible cluster is updated. And the participatory learning exclude the clusters that are redundant clusters. And this is evaluated all the time. And the redundancy is verified in terms of compatibility between clusters. The compatibility indexes among the cluster centers is computed here. And again, we use the Hausdorff distance for this computed. Here we have the idea of this participatory learning cluster. For example, here we have 3 clusters. When a new information arrives, xt, we compute the distance for this input for each cluster, and that is, I computed the compatibility measuring index, and I obtained the arousal index. If the arousal index is greater than a parameter lambda, a new cluster is created. This cluster created, the center is equal to the input. Otherwise, I updated the structure. And And I computed the most compatibility between the cluster and update the structure using or excluding the redundancy clusters. Okay? And the consequence. This is the problem, because the participatory learning resolves the problem with interval, but the problem is the consequence identification. Here, in the first results that I show here I show using ordinary least squares. For this, for each input that an interval, I transform in single values, and I computed the parameters using this method. And for each local model, I resolve this equation where the goal is determining this, minimizing this equation. I need to minimize the error. Okay, I determine the parameters that goal is minimize the. Obtain this, I return to the interval values using midpoints and half ranges. First, the results here. I use the data Ibovespa, the first that I showed you. We have the two sample. In sample, I used to construct the structure of the model, January 2000 to December 2011. And to analyze the performance of this model, I used the three last years. And I compared the performance using random walk, exponential smooth, auto-regressive integrated moving average, threshold auto-regressive, vector error, and the performance using interval multilayer perception. And the results here, I show you the one step ahead for testing. And here we have some descriptive statistical that I have the statistical for lower bound and here the upper bound. And we have significantly dispersion of this data for each series. And I show that this series don't follow a normal distribution. We have asymmetric distribution. Okay. I have the performance compared using root mean square error and the SNAP. And when I compare the performance using just the errors are really similar, and I use a statistical test proposed by the Ballini Mariano. When I compared the performance using two models, I compared the performance between two models. And here, first, I show the results about the errors. I show the results when I look just if I preview the lower bound and the upper bound. Of course, I would like to preview both because I have the variability here, but I show for each one. And I show that the interval models, multi-layer perceptron, and the fuzzy rule-based model that had a better performance than other linear models or random walk model. But here I have the performance when I compare the two models, like here. Lower bound, I have the random walk, has a similar performance, the exponential smooth, but the random walk is better than is different the performance the random walk and for example BCM or interval multi-layer perceptron or interval fuzzy rule based. And the same analysis is possible to upper bound. Okay. Now I have just 10 minutes about. I have the fuzzy semins. Now the consequence of the parameters of the consequence are estimated using a least square algorithm designed for interval value data, and I applied the results, applied this model using exchange rate euro-dollar, and I compared again using other models. Here, the difference, okay? The difference is that we computed the output of the local model. Here I computed two different local models for each lower and high performance using a linear model, but I computed it for each one. And the antecedent identification, I use the seat block distance. The centers are interval, and given the number of centers and the patterns, the goal is determine the fuzzy partition using this criteria. And the first stage of the algorithm was semins. I need to fix the membership degree and the weights, and I updated the prototypes and the solution results in two minimization problems. The second stage, the membership degree and the prototypes are fixed, and I update the weights like here. And finally, the last step is define fixed the prototypes and the weights. I updated the membership degrees. Okay. This is a traditional fuzzy semins, but using interval data. Okay? Now, the consequence, I needed to obtain the parameters associated with the lower series and the high series. Of course, here we have a problem because I preview two series. I have two series, and the parameters associated for each one is a single parameter, is not interval parameter. Okay, and it's not necessarily that the high series is high and the other is low. Okay, this is a problem. This is a point that we need to advance because I need to obtain the interval parameters and not specify values. Okay? And of course, when I use the recursive method using this huge method, and the application. The application, I have the exchange rate of euro against the US dollar. And again, we divide the sample into sets. And I compare the model using random walking, auto-receive, integrate, moving average, the back-end, interval multilayer perceptron, and the hold interval hold that is smooth method. And when I use the settings, I needed to define the number of centers and I needed to define the number of legs that I used to construct the input. I used 3 centers and 2 legs. I compared the results using root mean square error and the map for both series. And I compared using again the DWDM statistic. And I compared using another measure. Here I compared using direction accuracy because in forecasting, financial forecasting, it's important to indicate if the direction is okay and not the value, because the value is maybe the best result is that the last data is the best forecasting that possible to obtain the next time. But the direction is really important for the investors because I have if the price is low or high, this is really important. And here I use this. And now I show the results using these models. I show the random walk is a good performance, but I can't compute the direction using, because I don't have the differential, and I don't, it's impossible to compute the direction. But here I computed the performance using the other models, and I look at its interval fuzzy rule-based is really similar to the random walk, but the interval fuzzy rule-based or interval multi-layer perception has a good performance when I look the direction, okay? And here the DWDM test. I have the random walk has a better performance than auto-receive, and the hold and backend, but the similar results, the interval multi-layer perception and the interval fuzzy rule-based. This is a similar for low or high prices. And I think this is a good idea when I use a fuzzy rule-based model, because I have simple model. It's possible to interpretation of the rules. It's not my objective, but if I had interpretation, it's possible. And the accuracy is good when I compare in other alternative approaches. But I think we needed to advance in some subjects, like automatic selection of the number of clusters. Of course, in IPL, the automatic cluster is determined during the learning. Determination of the consequence. I needed to determination of the consequence using interval and not a single value. And after resolve these 2 points, I need to resolve the other is the interval evolving modeling, because the data arrive all the time. I don't have a clustering after consequence. The update of the structure need to update all the time because a high frequency data, okay? It's necessary to analyze the performance of this model in different organs and the application in different things, because it's possible to apply it in energy or series and other things. Well, thanks.
So now we have time for questions. Any questions for the audience? So thank you, Rosangela, for your presentation. I was wondering, you're working with the intervals, okay? Yes. But you use this minimum and maximum values. But sometimes when you have, this kind of variations inside, in the example that you gave in the financial market, you have, for example, outliers. How do you treat the outliers?
In this case, I don't try the outliers, but yes, I have the outliers. This is the point when I think the evolving method, because when I evolving method, the outlier is it's considered during the process, and
I see.
And here I don't.
You don't use it.
I don't consider this point, but it's a really important point because we have many outliers, and not just outliers, but I have some decisions of the markets that impact for exchange rate, like happen now in Brazil, for example. Okay.
Any other question? What happens when you have like rare phenomenons, like things that happens once that can be considered like, and you have like chumps? For instance, there's a local stock company here that, because there was a bad report on their finances, they lost like, I don't know, I think that it's like 50% of the value in one day.
Yes.
That's clearly unpredictable, but have you considered like if the model then adapts to that kind of chumps when something, I don't know, rare, strange happens?
Yes. The structure are updated all the time, and we consider when this happen because the structure changes. But I think the other advanced in the model, we are consider some exogenous information, because when I use the fuzzy, we can consider, I can put a rule that updates this information inside in the model. I think the results better than like here, because here I just use the data, the series, just not other variables are considered, but
yes, because it was like very straight. If you see the form of the price of the stock, it was like
yes.
there was some behavior, then
yes, and
then
the other day.
Yes, but then if you see it, it's similar to what was happening. It was like there was a shock, and
yes.
then it goes to the same behavior that.
And return it to the same level. Yes, because I think this is possible when I consider the other information, because when I have a structure change like this, it's impossible to preview, okay? But if I have some information about the market, about the temperature of the economy, this is the impact of the forecast, the exchange, or other series, of course.
Question over there.
Hey. Hi, Rosangela. My question is similar to the fourth question. When the serial time change the day, how many times do you recommend they recalculate the model per day?
Sorry. Okay. When I have the evolving model, all the time the structure is evaluated. For each time, I can adjust the parameters, okay? Because it's, when I new information arrive, I can update the structure, and the performance is better, of course. The next time I use it, the next time the change that happened before, and this is good, okay? This is good for control system, for example. It is really important. It's not necessary when forecasting, but in other cases, the change of the model is really important. In robotics, it's important too. It's possible to apply the evolving models, okay? There are many structures in the literature about this.
Okay, any other question? So I was wondering, because I have some applications in industry in which we have to make the kind of forecasting with not just one step ahead, as you mentioned, but some steps ahead, because of the characteristics of the production lines. How do you feel your results will change if you change the number of steps ahead?
I have a paper which I applied using 5 and 10 days ahead. The performance of this model is better than the linear models. Interval multi-layer perception has a good performance, and the fuzzy also. And I think it's possible to review. But I think, like Kimmy's said, the long time we are dead, then sorry, but I don't believe the forecasting for a long time. I think we need to update the forecasting during all the time it's possible, because the model is not good.
So any other question? So then let's...
There are no further questions. Here, the souvenir from your visit to Montevideo, Europe.
Thank you. Thank you so much.
Yeah, so thanks a lot for attending this session. I think we will return at 4 p.m. Then we have a coffee break now.
Okay, welcome again. Good afternoon. We are here to continue with the conference with the second in-person paper session. The first talk is titled Kaizen Programming for Predicting Numerical Linear Algebra Operations Performance by Jimena Ferreira, Ernesto Dufrechou, and Martín Pedemonte. The presenter is Jimena. Okay, you can start.
Good afternoon. I just wait for the presentation. Sorry. Well, I will present our work that was about implement a classifier to select different algorithms. Can I help you? It's not that. Thank you. Good afternoon, everybody. Well, I present our work. We work with the product of a sparse matrix and a dense vector that is named SPMV. That is an essential block of many numerical methods, such as iterative solution of sparse systems of linear equation of large dimensions. There is a lot of implementation of this kernel for many computing platforms. For example, there are several implementations for GPUs, and the performance is difficult to predict because it depends on the memory layout of a sparse matrix. So machine learning can be helpful to select several implementations according to the characteristic of this sparse matrix. So, in a previous work, in the work of Dufrechou and collaborators, they worked with a black box classifiers applied in to select 6 GPU routines for the CSR sparse format. And they found that the best result was with the baguette tree, that was around 80% the accuracy. But this method, this model classifier, does not explain the link between matrix feature and the performance of the routines. So why using Kaizen programming? Well, it's a promising supervised machine learning technique that obtain models that are mathematical expressions, and is useful to understand the performance of method. And once the models are obtained, they are fast to apply. So Kaizen programming is an hybrid model that was proposed by Veloso de Melo in 2014. Is an algorithm that combines evolutionary algorithms with statistics for solving symbolic regression problems. The algorithm aims for a model that is a linear regression combination of non-linear bases. So the non-linear bases are constructed and modified with genetic programming, and the coefficients of the model are calculated by a linear regression such as ordinary least square. So the Kaizen programming starts with the generation of the initial population. That is each of the bases of the model. Then there is a stage of creation of the offsprings. These offsprings and the initial population are combined to create the expanded population, and then there is a stage of calculation of each coefficients of the expanded population, and then a stage to eliminate some bases based on the coefficient value and the p-value of the coefficients. These three stages are in a loop, iterative, until some criteria of stopping criteria is reached, such as the number of iterations or generations, or some metric related to the R-square. So we worked with two approaches to make a classifier. Kaizen programming obtain models, but that are not classifier. So we have to make some changes to produce a classifier. In the first approach, we work with the REC approach that is based in a runtime estimation classifier. We have the input data, the future of the matrix, and the runtimes of the 6 GPO's routines. Then we make a transformation of the output with that mathematical expression. So in order to reduce the large values and have only positive values in the output variable, then we make the symbolic regression of the outputs, of each of the outputs, and we make 50 execution of each search, and then we apply a classifier model that is the minimum value of between the outputs. In the other approach, we work with a discrete function, so we name it DFC approach. We started with the same data, but in the stage of transformation of the output variable, we transform the value of the output as 1 if the routine was the best routine, or 0 if in other case. And then we apply a search by Kaizen programming, also 50 execution for each search, and then we apply the classifier model as the maximum of the between the routine estimation. So our experimental case was we worked with a sparse matrix stored in compressed sparse raw format that only store non-zero elements and the indexes. We worked with 6 routines that are here because there is no a best solution of what is the best for some type of sparse matrix. So we worked with cusp vector, cusp sparse naive, cusp sparse merge, adaptive, PCSR, and light SPMV. We worked with almost 3,000 data points that vary in the number of round column and number of non-zeros. And we have 8 output input variables, such as the number of round, the number of column or non-zeros, the minimum and maximum number of non-zero elements in a round. And we work with 6 output variables. One that was worked with the mean of 100 execution time of each routine for working in an NVIDIA GPU. And we implemented the Kaizen programming in Python using the deep package for the GP constructions and scikit-learn package to the linear regression. And we use as function sets the most common functions such as sum, subtraction, multiplication, etc. And 2,500 generations, and the other parameters such the initial and maximum depth and crossover mutation and offprint size based on previous works. And we worked with 3 different configurations for the population size, that was 8, 10, and 12, and we evaluate how they work. So we work with 2 configurations to evaluate the difference between in the performance of these searches. We apply the Freeman test and the Wilcoxon-Sinor rank test to answer if the error distribution on the 50 execution of each algorithm are different. So we used a confidence level of 95% over the distribution of the root mean square error over the validation points. So in our first result was about the symbolic regression in the first approach, in the reg approach. We compare the 3 configuration of the population. Based on the statistical test, we found that with Freeman test, the 3 output variables are not statistical. There are not statistical difference between them, between the configurations, and for the rest of the variables, with the Wilcoxon test, we found that the median of the root mean square error distribution obtained with the size of 12 was lower than the other 2 configurations. And for the other approach, the DFC approach, we make the same comparison, and we found that for 5 output variables, there is no statistical significant difference between the size configurations. And just for the first output variable, we found that the median of the root mean square error distribution obtained with a size of 8 was the lower than the other 2 configurations. So we apply the model classifier to the size to each size and compare the accuracy. So in the table we can see the accuracy for each approach, for each size. And we find that the approach DFC, that is the binary classifier, generate a better classifier than the other approach in all cases. And in the case of the size 12, we find that is better than the other sizes for the 2 approaches. And the classifier using the binary classifier has an accuracy that is competitive with the obtained in the previous work, that it was around 82%. In our case, is almost 83%. And then we study the classification, but just with 5 input variables. We discarded or not used the 3 most expensive or the most cost expensive, computational expensive ones to get. So we make the same work to the same searches, and then we find that the accuracy obtained with the binary classifier with 12 as population size is almost the one that we obtained with the 8 input variable. So we can make a good classifier without use all the input variable, and it's good because the computational cost of the obtain the future matrix is severely reduced in order to obtain the classifier. So in summary, we developed 2 approaches to generate a classifier that allows selecting the best routine based on a sparse matrix characteristic using Kaizen programming, when we found that the rec approach is based on the symbolic regression of the runtime of each routine considered, and the DFC approach is based on a symbolic regression of the best routine using 1 or 0 as value of the output variable of each routine. And we found that the best approach is the DFC approach, and with this strategy we found an accuracy of almost 83%. And as our future work, we pretend evaluate these techniques for predicting the performance of other sparse operations such as the SPTRSV, extend the models to consider the characteristic of the hardware platform as input variables, and analyze the model producing using symbolic regression to understand the performance of a sparse routine better and suggest possible optimizations. Thank you very much.
Okay, thank you, Jimena, for the presentation. We have a time for a short question. No? Okay. What is the between TFC and REC? There are similar to implement, one harder or not, or similar, because DFC is the best of one.
It's very similar to implement because in the stage of the transformation of the output is the same. It's a mathematical expression. Okay. And the search is almost the same. And then it just calculate the mean or the maximum value. It's very similar.
Nice.
Yes.
Thank you.
Thank you.
Okay. Thank you. Clap, please. Okay, we continue with the second talk of the session, titled A Many-Objective Optimization Approach to Generate Synthetic Datasets Based on Real-World Classification Problems. The authors are Stefano Pereira, Pericles Miranda, Tiago Franza, Carmelo, Bastos Filho, and Tapasi, and the presenter is Carmelo. Thank you very much. You can start.
So, good afternoon. Sorry for being here again. Until the end of the conference, I have some papers. Actually, I'm going to present this paper, but the paper was done by the people from the Federal Rural University of Pernambuco. The student is Stefano Pereira, and his advisors were Pericles Miranda and Tiago Franza. Unfortunately, they did not make to come, so they asked me to present. I have collaborated in this paper, actually in the more related to the many objective optimization, not with the problem itself, but giving some hints regarding the many objective optimization. But I will try to present, and if I can answer some of the questions. If I cannot, we're not able to do this, we can forward the questions to the authors. Okay. So the point here is that we have this new need for generating synthetic datasets, and the point is that we are using a lot these new techniques from artificial intelligence using these data sets to, for example, training the models and to produce some of the models for the market from the economic sectors. And the question is that sometimes these data sets are not the best data sets to create these models. So some of the approach that you can find in the literature is to find ways to create data sets that are more suitable for training the classifiers. And we have some other problems related to this kind of task. That is, for example, sometimes when you have data that are from companies, they do not want to use the real data and expose the real data set, okay, for the market, because they have, things related to NDAs and so on and so forth. So some of the tasks that they are very willing to do is to create robust data sets, to keep the secrecy of the real world data, and to create balanced data sets that can allow you to create models that can work better for different real situations. Okay, so here you have some citations was provided by the student regarding this point of related to the synthetic data sets. And the point is that we are starting to use more often this kind of techniques, and we have to think about on what we are doing and if we are doing this in the right way. I know that we have very different sets of tools to do this. For example, the GANs, the Generative Adversarial Networks. But even when you're doing this, you have to check what is happening with the data set that you are creating. Okay? And one point to assess the quality of these data sets are to use the complexity measures that you can apply and analyze the information regarding the features, the instance, and how this data within your data set is distributed. So we have different measures, different metrics that could be applied to analyze these features of the data set. And the point is that we have lots of features, lots and lots. If you look in the literature, you see that we have thousands of them. And sometimes you have to choose some of them to analyze and to check what we would like to have in our assessment. For example, some of the data complexity measures tries to identify or to measure the linear the linear power of classification that we have, considering the class that you have. But some of the other metrics you try to assess, for example, the imbalance of the data set, or the metrics, you try to assess the number of points that you have in the frontiers of the classes, of regions that are near these frontiers, and this is the point. Okay, we have to analyze some of these metrics and analyze the data set according to these metrics. So what we are proposing in this paper is to analyze, for example, take a problem and have a kind of framework to produce or to balance, to create a kind of new instance to balance these data sets using a very structured framework using these metrics. But to do this, we have to kind of make the metrics to have the same characteristics that we have in the original data set. So the first step is to have the problem. Then, given the problem and the data that you have regarding the problem, you have to extract the complexity values. For example, in this works, we are using 4 different measures, 4 different metrics that gives different information regarding the data set. For example, C2, L2, N1, F2. For example, one gives information about the quality of classification that you have when you try to divide the groups in a linear manner. The other one, when you are trying to assess the number of the or percentage of points that you have close to the frontiers. The other one related to the regions that you have close to the frontiers. Okay, so are different measures, different characteristics that we'd like to have. And the idea here is, given that we have these properties, okay, we can try to use another model that has the same statistical characteristics that we have in the original data to create a new set of unlabeled data. Okay, this is the point. And doing this, how can I say, the proposal here is to take this new data with good statistics, related similar statistics to the original data set, and compare with somehow with the measure that we have from the original data set, using a many objective algorithm, optimization algorithm, to create the synthetic data set. Okay? But what we are trying to do here is to take into consideration these 4 metrics, because we would like to have the same percentage, or at least roughly the same percentage of data in the frontier, of the classes, the same characteristics regarding the linearization process, the same characteristics regarding the regions that are close to the frontiers, and so on and so forth. And what we do is we compare the metrics that we have concerning the synthetic data set to the values for the metrics that we have for the original data set. And then we can have 4 differences, and we use these 4 differences for calculating the fitnesses that will be used as the quality measures for the many objective optimization algorithms. Just to remind you that we have different types of optimization algorithms, artificial intelligence based algorithms. There are some that are related to evolutionary computation, others related to the swarm intelligence. But in this paper is a first paper. We are using a very well-known optimization algorithms for many objectives. Many objectives in this area means 4 or more than 4 objectives. And you see that when you have many objectives, you have some difficulties in defining the dominance criterion. I don't know if you are aware, but we don't have time now to disclose about all this information. I can give you some other information if you want after the presentation. But the point is that when you have this kind of characteristic, what we have to do is to use algorithms that can deal with this problem. The most famous algorithm is NSGA3. So we deployed the NSGA3. That's a very widely used algorithms for this kind of proposal, but with these 4 fitness functions. Okay. So here we have the entire proposal. We have the problem that we have selected. We extract the complexity measures. Then we calculate the properties that we should use for the instance generation, and then we compare the data set using the many objective algorithm to find which instance from the unlabeled data set I should use to have a set of data that is most similar regarding the metrics concerning this complexity measures. And then when I find this, the goal is exactly to provide a synthetic data set that has the similar measures regarding the original data set. Okay? So, as I mentioned, the whole work I'm just here to present, and I give just some brief collaborations, but the guy who worked a lot in this project is Stefano. He's a student from the Federal Rural University of Pernambuco. He worked with well-known libraries that we have available for developing these tools, scikit-learn, matplotlib, pandas, numpy, and that library that's a library that you can find the many objective optimization algorithms. And we deployed in SGA3 exactly because it's already available over there. If you want, you can take a look and you can find the entire project available in the GitHub. Okay? So, just to show some preliminary results, we analyzed 4 well-known problems that we have in the literature. You know, we have this iris. It's not just a toy problem, but just for you to have an idea and on how the proposal works. We have this width, variety, immunotherapy, cervical cancer, and as you can see, and you can find all the results in the paper, we chose these problems because we have different characteristics of the dataset, the original dataset. So we have, for example, in the iris just 4 attributes, but in the cervical cancer we have 19 features. We have different number of instances, different number of classes, and for sure we will try to assess the proposal with more difficult data sets. Okay? Just some, as I mentioned, some highlights regarding the results. The paper has more results, and we plan to publish a more complete paper in the future. Here you can see the results regarding the features that we have in the original data set, and the values that we have obtained for each one of the fitness functions, for each one of the metrics that are the fitness functions that we use to code the metrics. And as you can see, the values are quite close. In this first set of results, we are dealing with the iris data set, and the point here is not to balance, to recreate, to create a synthetic replication of the data set. And as you can see here, you have a new set of instances that they preserve the characteristics of the original data set with a very similar values for the metrics. This is another case. We use another original data set that is called the cervical cancer data set. In this case, as you can see, the values for the target for each one of the metrics that we are trying to seek with the many objective optimization algorithm is quite close to the values that we obtained using the optimization algorithm for generating the data. And from the results in the top, you can see that in this data set we have a lower number of points of instance, but we managed to create a large number of instances for the synthetic data set with the oversampling procedure, but maintaining the same values for the complexity measures that we deployed, at least we deployed. You can ask me, okay, how did you do this? At first, we tried to find some different metrics that can reveal different characteristics of the data sets. But nobody will say that they are the better. For the further future works, we intend to use other metrics and investigate the relation between these metrics, and if there is one metric that's it's more difficult to optimize, and so on and so forth. Okay, so the goal here, we just managed to finish the presentation, but the main idea here, I will not read the slides. I will make it available for you if you want, as the paper. Is exactly to try to propose a new way and a framework to create or to oversample points using these measures. Okay, the point is that people are trying to generate data, but sometimes they respect the sum of the statistical features of the samples, but they are not how can I say, they do not pay attention on these specific points that are related to the classification problems, for example, in this case. Okay? I'd like to thank you a lot, and I'm available to try to answer the questions if they are related to the optimization process, or even if I do not know how to answer, we can try to forward them to the other authors. Okay? Thank you a lot.
Thank you very much, Carmelo, for your presentation. Any question? I have a question. Your problem is integrally defined by the instances, or you consider another definition? What is your problem defined? Your start point are the instances of the problem, data sets of instances of the
Yes.
problem, or you have a formal definition, a model of the problem? I don't know.
No, we don't have
predicates.
Yeah, we don't have a. What the goal here is to, given a set of points, given a set of instances, we would like to have other data sets that are related in terms of complexity measures to the original data set.
Okay.
This is the point.
You assume that the data sets are representative of the real life problems.
Yeah, sometimes it can be any kind of data set. The point is that
real data of the problem.
we can use real data. We can use any kind of data we want.
Okay, but the quality of...
Yeah. But sometimes one of the worst parts of work with data is that for most of the applications, it's very expensive to have, data from real data. Sometimes you have some problems where you have very unbalanced data sets. So we have, for example, for one class, you have 1 million points, and for the other class, you just have 100 points. So it's quite confusing for the classification algorithms. I know that there are some approach that try to tackle this problem, but even this sophisticated approach, they have this kind of problem with dealing with data sets that are very unbalanced.
Okay. Thank you. Okay.
So, in order to understand the output, the algorithms, the Pareto set is the data set, the synthesis data set, or just one solution of the Pareto set is a synthetic data set. This difference, and I can understand.
Okay, great question. Thank you a lot for doing this. Actually, what we have is we try to optimize, and we create a Pareto considering the 4 objectives. In this case, the 4 objectives. So each point of the Pareto, you have, the different distributions of the points, and then you can select which one you would like to have. Okay, and when you have dominated solutions, they are taken away considering the objectives, the fitness functions that we are using during the optimization process. Did you get it?
For example, if you have 10 solutions in the Pareto set, if I take one solution, this one solution is a complete synthetic data set, different of the other, or the 10 solution is the data set, the synthesis data set generated for the algorithm?
I got your point. Actually, we use the dominance concept to exclude the dominated solution, but we evolve the data set considering a combination of the information that we have generated by the instance generation to have, the points that are close to the... But we can change. If you want, we can change. I got your point. And if you want, we can change to model as a single solution, to create different possibilities for the entire representation of the data set.
Thank you.
I will think about it. Thank you a lot.
Thank you a lot. Carmelo. Okay. Continue with the third talk of this paper session. The title is Application of a Genetic Algorithm with Social Interaction to Search-Based Testing by Adilson Neto, Rodrigo Pereira, and Roberto Oliveira. Adilson? Okay, Adilson.
Okay, my name is Adilson Neto, as you mentioned, and I'll be presenting the paper titled Application of a Genetic Algorithm with Social Interaction to Search-Based Testing. So my professors are Dr. Roberto Limão, Dr. Rodrigo Lisboa, and this is an ongoing research based on my master's degree, so it's ongoing, it's not finished. And I'm doing a master's at the Federal University of Pará. So first going on what we're with the agenda, it's a very simple agenda, so we're going basically by why this is important, introduction, the related work that exists in the literature, what do I mean by software testing with genetic algorithm social interaction, the state of the art, experiment results, and of course the references and the acknowledgements. So testing software, of course this is only one example. There are many researchers that gather those numbers, but testing as an activity can take from 30 to 50% of the total effort or time in software development. So it's important that we research into techniques and tools that can automate tasks so that we can spend less time testing with the same quality, of course. And this is the relevance of this. So genetic algorithms have been applied to software-based testing, software testing in general. So I'll go into detail what do I mean by search-based testing, of course. But it has been used in mutation testing, in structural testing, and exception testing, and many other sub-areas of testing. So because of this, the flexibility that the generic algorithm has, because you just have a fitness function and you can do many different types of optimizations. So they also have been compared with the hill climbing and the vertical swarm optimization for different specific tasks. So in this case, I'm just going to introduce a mutation operator and compare it with the state-of-the-art for genetic algorithms. So I'm not comparing with other methods. Going forward a little bit, so what do I mean by search-based testing? So search-based testing is just the application of optimization techniques to the generation of test data. So the problem that we consider here is the generation of data that will be used for testing in some way. So in this case, we are using optimization techniques. So we need, other than the data, we can have the data, but to use this data for something, we should have some sort of methodology. And in this paper, specifically, we're going to use the branch coverage. So putting in other words, what we want is we want to generate data, and we want to have this data reach a specific line of code. So each run of the algorithm, we want to optimize in a way that we want to reach a specific line of code. And for example, if we want to cover 5 lines, we have to run the algorithm 5 times. And I imagine most are familiar with the genetic algorithm, but I'll just do a simple overview. So essentially, we have a fitness function, like many optimization techniques, and this fitness function will represent how good a solution is. And initially, we have an initial population in which each solution is just a possible solution to this problem. So we have a population, and we're going to select and do the crossover and the mutation, which essentially means we'll be selecting from this population to generate an offspring. We're going to combine those parents and mutate them. and we repeat this loop until the termination criteria is satisfied. So this is just an overview. But so to have a genetic algorithm or optimization, we have to have the fitness function. So here on figure 2 we have a function that's just a kind of a simple function to show how exactly does this fitness function will work. So as I mentioned, we want to each line that we want to reach is a run of the algorithm. So for example, imagine that we want to reach the point return 0 there. We have to first go to the point that x must be greater than 10 and x must be greater than y. So we have these two control nodes. And how does the fitness work in this kind of problem? We have the approach level and the branch distance. So the approach level is how many control nodes we have reached towards that objective. So for example, if we reach x is greater than 10, then we would increase the approach level. The approach level is greater. And the branch distance means if we have not reached the final objective yet, in this case return 0, and we are, for example, stuck in f, if x is greater than 10, then how close we are to it. So in this way, the more control nodes that we reach towards this objective, we have a higher fitness, and the closer we are to reaching the control node that we are stuck at, is the greater the fitness is. So the formula of the branch distance is just based on the value and the expected value of this expression, but the core idea is that we want to measure how close we are to reaching this control node, and this is a way of to normalize this fitness function. So you can see in other papers the branch distance being defined in different ways, but the point is that it's normalized and that we have an increasing fitness when we're closer to reaching that point. And depending on the selection method, this can vary, but we'll keep on. The tournament type was a tournament selection, so essentially it would not be affected by fitness that are too close to each other. So it would not be affected by how it would not be as affected by the normalization as other selection. And the crossover is just a single point crossover. The mutation is the core of this paper, so I'm going to explain this a little bit further. So the idea, what do I mean now? What do I mean by social interaction? So we're not going to simulate social interaction. So it's just a way of having dynamic mutation rates inside the algorithm. So essentially, we're going to be based on the prisoner dilemma game, which is we're not going to how can I put this? As I said, not going to do a simulation. We run this game in a way that each element, each solution will be assigned a random strategy to play this game. So they will always cooperate, always defect, get a random strategy or tit for tat. For people who don't know, tit for tat is basically the agent will first cooperate and then he will just mimic what he has seen on the last game. So if the other cooperate, he will cooperate. And at the start, each slot of the solution will be assigned a random strategy, and they will play a game with the next neighborhood. So individual 0 will play with individual 2, and 3 with 4, and so forth. And in this way, we'll change the mutation rate following this formula. So the important bit is that we have a random number that's just a random number with mean 0 and standard deviation of 1. So it can be minus 1, 22, 23. It's just a random number. We have the domain size. So we're going to the mutation will be proportional to the domain size, and P will be the payoff. And in this case, it can go from 10% to 0.01%. So this is this is why the game matters in this algorithm, because this will determine that in some regions the mutation will be greater, in some other regions the mutation will be smaller, and since some individuals have a random strategy, then this rate will change in approximately the expected value. Of course, is 25% of the population because the strategy assigned is random. So a 10% rate of elitism was used, and the IEEE criteria was 250 generations or 100 coverage found. That means that the line that we want to reach was reached, so there's no point in keeping the algorithm going. And talking a little bit of the state of the art we have on the genetic algorithm, is the Daimler-Chrysler system, and it's composed of six subpopulations: selection with linear ranking, discrete combination with crossover, 10% rate, and a few migration elements that you will notice are similar in a way to what we have done on this paper, but it's more complex to implement. So the element that's important here is that this summatory is a random number and can go from 0 to 10, but you can notice that we have a 10 to the power of minus p. So we have 6 subpopulations, each one has an index, and depending on what subpopulation the solution is, then we'll mutate more or less. So this is a multi-population genetic algorithm, and it will rebalance itself based on something that I will present a little further. So just going a little bit. It will, at each 20 generations, 10% of all subpopulation individuals will be exchanged. So just go over this. And it will also linearly rank all of these subpopulations, and they will be rebalanced at each 4 generations based on this formula for progress that is based on the rank. So what this means is that if big changes in the population are making more progress, then we have more individuals on this subpopulation that is having more progress. And if we are fine-tuning, then we have to more individuals will be migrated to the population that does more fine-tuning. So you can see the difference between this and the paper, because in our case it is fixed. So it will be the places that have a high modification will keep on doing this to the end of the execution. The dataset uses this list of functions. Those are all Python functions. Some of them are on the Python itself, and some are just open source. So the number to the right is just a number of branches, as I call them, on each function. So each function can have many branches. So I just do that because I think I have 4 minutes left, and they all have to be instrumented manually. So that one thing that you might notice, there's no statistical significance test. So what we have is 20 executions for each algorithm, to each problem, and to each branch. So there's a lot of executions. The diversity was calculated using the Euclidean distance, and the random search was used as a benchmark. The benchmark here means that that this random search will determine what kind of problems they are easy to solve, because if random search solves them, then they're pretty easy, and if they don't, then they're somewhat harder. So that this is a fitness plot. So the mutation has a higher convergence for fitness. So this does not mean that this is better than the state of the art. It means that there is a subset of problems that it outperforms the state of the art, and this means that this is viable, not that this is best because the data set is not that big. So there are other data sets, not exactly on Python, but will be expanded. The idea is to expand. And just going to the diversity is pretty high. I'm not going to time. I'm not going to delve too much into the diversity, but the idea is just that there are parts of the population on this mutation that will keep on being aggressive on the mutation. So it will disperse too much, and the diversity will be too high. In this case, I think I would consider this a problem and not a good thing that diversity explodes in this way. So there is an ongoing effort into making this more fine-tuned instead of having it randomly exist in the population without having many subpopulations and migrations, in the case of the Daimler. And you can see that there are half of the functions are pretty easy. They were solved by random search, and they have similar performances, but the difference appear on the functions that you can see. This is the number of iterations that it took to resolve on average. So, the function to the right is interesting because it's actually a string, a fixed size string that is treated as a list of numbers. So it has it converges faster. So they're not just functions that takes numbers. They can take strings, but fixed size strings. And this is my references. And my acknowledgement is just the Laboratory of Bioinspired Computing at the Federal University of Pará, and the Computer Technology Group at the Federal Rural University of Pará. And also I have to thank the organization for making this possible. And I think this is it. Thank you.
Okay. Thank you, Addison, for your presentation. Any questions? You have one? Okay. Please wait for this one.
Good work. Congratulations. Send a hug to Professor Limão. I was wondering, because you said that the most relevant part of your contribution is to use the mutation. So why did you decide to use the genetic algorithm instead of other evolutionary algorithms that can provide, for example, hypermutation with different applications of this new operator that you're proposing?
Okay. So this is more like a historical reason, I think, than a really technical. The research itself is what you use this algorithm that Dr. Limão also researched to this class of problems. So, but I decided to simplify it and remove many parts of it so you can see that the mutation is pretty simple. And I would say that even that you can remove this social interaction part because it followed like that, but after simplifying, I don't think it's relevant. I think the relevant part is just the mutation. So I don't know if that answers your question, but this was a progress. It was several steps led to this specific implementation.
Another question? No? Okay. Thank you, Addison, again. Okay, we continue now with the conference with the third in-person paper session. The first talk is titled Early Prediction of Generalized Infection in Intensive Care Units from Clinical Data, a Committee-Based Machine Learning Approach, by Flavio Fonseca, Ariane Torcate, Ana Clara da Silva, Víctor Freire, Gilles de Faria, João de Oliveira, Flavio de Oliveira Júnior, José Carlos da Silveira Júnior, Dayan Gómez, and Wellington Pinheiro dos Santos. Okay, Flavio, sorry, you can start. I don't know. Here. Is there on the table? Okay?
Hello.
This one.
Well, hello everyone. So, as said, my name is Flavio. I'm from University of Pernambuco, and I'm going to present the paper, Early Prediction of Generalized Infection in Intensive Care Units from Clinical Data, a Committee-Based Machine Learning Approach. Our research group is from Pernambuco. I'm from University of Pernambuco, but other members of the group are from Federal University of Pernambuco and from the Hospital of Restauração in Recife. To introduce that work and contextualize a little about the problem, I'm going to talk after about the sepsis. Much of you could know the sepsis as the generalized infection, but the sepsis is also known as an organic dysfunction of the body or an exaggerated reaction of the body to an infection. Some of the clinical manifestations of symptoms of the sepsis can serve also as a warning to the health professionals to understand and diagnose the sepsis, such as fever, increasing of number of blood cells, mental confusions, among others. However, it's worth to mention that most of individuals affected by the sepsis are not diagnosed at the time when they arrive at the hospital or at the intensive care units. So the recognition of in the early stages of the sepsis are especially a very big medical challenge. So in the light of that problem and viewing the potentials of the machine learning in the algorithms of classifiers machine learning, the main goal of the project, of that research, is to propose an hybrid model among several classifiers and deep neural networks for the early detection of the sepsis based on clinical data. To that end, we find the dataset from the PhysioNet database launched in the cardiology challenge from 2019, and that was developed especially to the prediction of the early stages of the sepsis. About the method that we used, here is a diagram of the methodological routes that we proposed. First, we had the preprocessing of the dataset, of the PhysioNet dataset. After that, we treat the missing values of the data. As a health dataset, we had a lot of missing values. After the treatment of the missing values, we divide the dataset into a training validation group and another test group. With the training and the validation group, we made a class balancing, viewing that the dataset is very unbalanced. We had a very big number of instances of no sepsis and a very few number of instances that are sepsis, that are labeled as sepsis. With that, after that preprocessing, we started the first experiment that we called an exploratory experiment. In that exploratory experiment, our objective is to identify and try to find the best models or classifiers and their best hyperparameters. To that, we applied a grid search in each classifier to find the best hyperparameters. And that first experiment, we repeated it 30 times to got a solid statistical base. After that first exploratory experiment to find the best models, we built our hybrid model. Our hybrid model was composed by a classifier committee, and that hybrid model was also trained and tested as the other models that we did in the last stage. And at the end, we analyzed and compared the results of the hybrid model and between the other classifiers. Continuing about the methods, talking about a few about the dataset that we used. The PhysioNet dataset was developed in the Computing Cardiology Challenge from 2019, and as I said, it's a health dataset collected in intensive care units from 2 hospitals, and because of that, it had a lot of missing values. Around 68% of the point data are missing values. Much because of the hospitals are not able to collect the values, the data from the patients hour by hour. In intensive care units, it's not so possible to collect. This dataset is a data frame when columns are referring to the features, referring to vital signs, laboratory values, and demographic characteristics, such as age of the patient, time when he arrived at the intensive care units. And the instance of the data frame is referring to the hours of the patient, and we had around 1.5 million hours in this data set. And in the right, we had a table resuming the statistics of the data set. We had 1.5 million hours of registers that from that total, 27,000 hours with sepsis. So we can see how unbalanced that data set is. Number of patients are 4,000, and the sepsis prevalence is 7.2%. Continue about the method. As I say, to treat the missing values, we observed that each feature of the dataset, each of the 40 features, follows a normal distribution. Most of the features follows a normal distribution. So because of that, we decided to apply a Gaussian filling to treat that missing values. In that up graphic, that up histogram, you can see the distribution of the pH of the blood with 93% of missing values. So it's a huge number of missing values. And in the bottom graphic, you can see the same histogram of the pH of the blood, but after the Gaussian filling without missing values. It's not the same distribution, but you can see that's pretty similar to the original distribution. So we apply that Gaussian filling to every feature of the dataset. About the class balancing, we decided to apply the synthetic minority over sample technique. It's also called as SMOTE, a technique to balance the classes. We create synthetic key instances of the sepsis label. The SMOTE was applied with a k-neighbor equal to 3. Continuing, the first experiment that we applied, the exploratory experiment, we decided to carry out some classifiers, and the first was a random forest, a nuclear perceptron, a logistic regression, a decision tree, extreme and light gradient boosting, a gradient boosting, a cat, and other boosts. After finding that in that first experiment the best models, we decided to build our hybrid model with the best 4 algorithms that we tested before. In Ensemble, combining the 4 best algorithms. The metrics that we used to both of these experiments are the accuracy, kappa index, sensitivity, specificity, and area under the rock curve. Talking a few about the results. These was the results of the first experiment. Here I am not showing the results of the 90 algorithms that we tested in training, but we have the best algorithm, that is the random forest, with the hyperparameters after the grid search, max depth equal to 0, number of trees equal to 500, and criterion entropy. The same way, we had the worst model here is as the gradient boosting with its hyperparameters. In the up, I had the results of the accuracy, sensitivity, and specificity of the best model, that is the random forest. As I said, we repeated that experiment 3rd time, so we had the standard deviation in the right. The graphic is comparing both the best and the worst model, but it's important to say that as we tested 9 models, none of the results between the 9 models are so different between the results. So because of that, we decided to build the hybrid model, choosing 4 classifiers that are from different classes. As I said, the best model here are the random forest, and the worst are the gradient boosting, but the most of the classifiers that we tested didn't reach results so different, so better than the random forest and so worse than the gradient boosting. Because of that, the hybrid model that we decided to build, the hybrid model, trying to follow the variability of the models, making the ensemble much more robust. That choice helps to decrease the chance of the similar models falling into the same classification errors, such as if we choose the random forest and the decision tree as a component of our hybrid model. Two classifiers from the same type maybe could fall in the same type of error also. our hybrid model reached accuracy of 95%. Kappa index 0.15 is the worst result, and from the same way the sensitivity 0.28. Specificity is also very good as the accuracy. In the area under the curve, the rock curve of 0.74. That results are from the test step, not from the training and validation. Also, you can see the confusion matrix in the right of the test step from this hybrid model. You can observe that the hybrid model has a much better performance to detect the non-sepsis instead of the sepsis class. That maybe an hypothesis is because of the how unbalanced the data set is during the test steps. As a conclusion, we could see that machine learning has a lot of potentials to solve this kind of problem, as we tested in training 9 models and a hybrid model, an ensemble. And machine learning is serves as an alternative to assist the early diagnosis of sepsis. Our hybrid model reach high accuracy, specificity, but by the other hand, low sensitivity. And we could see that we could observe that the importance of carrying out a robust preprocessing of the data set, especially because the number of missing values and the unbalanced the data set is, how unbalanced the data set is. And another point is that during the study of the related works, we observed that most of the works that used this data set from the cardiology challenge decided to apply a metric called utility. That's not common to the health professionals. So we raise that point as a point to get better. So we decided to use metrics that are more common to the biomedical engineer, such as sensitivity, specificity, or even the accuracy. As future works, we are working in a temporal preprocessing of the database. We are making windows of 6 hours instead of 1 hour that we used in that research. Making a selection of the most significant features with PSO. In the end, making a different class balance as a undersample instead of the oversample that we did with the mode in that research. That's it. I'd like to thank you, the University of Pernambuco, for giving me the opportunity to be here, and the research group also to supporting my participation in the conference. Thank you.
Okay, Flavio, thank you very much for the presentation. Any questions? No? Any question, please? Yes? Yeah. Okay.
Congratulations for your work. I would like to ask if this data set keeps track of the patients. So you could say that how many patients of this data set has sepsis? Because I was wondering if maybe for one patient you have multiple hours of measurements.
No, I think I show this style of the data set, but what we have is 1.5 million hours, and each hour is a register of one patient. So we got 1 hour of that patient, second hour of maybe the same patient or another patient.
Yeah, but this data set has a ID for the patient. I know you cannot identify it.
No, there is no identification of the patient. I don't know, maybe it's I don't know why, but there is no identification. Just the age of the patient, where he's from the time that he arrives at the intensive care unit, but no other identification. that's common to the health datasets. There is no identification, I think.
This method is also applicable to other disease, other infection. What do you think? Or is very particular?
This architecture, you said, as I said, this is still an initial and exploratory experiment from our research group. Our research group is from computing biomedical, so we are trying to explore amount of architectures to solve this kind of problems. But I don't know, maybe it could be help to solve other kind of problems, but I couldn't affirm that. So
yeah, okay. Okay. Thank you, Flavio, again. Okay, we continue. The next talk is for the paper titled A Comparison of Generative Adversarial Networks for Image Super Resolution. The authors are Patricia Covelli, Sergio Nesmachnow, and Shamal Tutut. Presenter is Patricia. You are ready? Okay, let's go.
You hear me? So I'm going to talk about the work we did with Sergio and Patricia about GANs for super resolution. So we'll talk first about a little bit of the methodologies we worked at and the datasets, the metric, and the experiments. What is super resolution is the recovery of a high resolution image from one or more low resolution images. This has many applications. For instance, for computer vision, let's say an e-commerce web that wants to enhance their images, for satellite imagery, for medical reasons, for security, and so on. And what we're going to see today is a comparison of some methods of GANs for super resolution, particularly SRGAN and ESRGAN on a standard dataset we're going to mention later. And then we're going to see the transfer learning capabilities of one of those methodologies on another dataset. So single image super resolution is generating a high resolution image from a single low resolution one. And this problem has many ways to be tackled, which are listed here. Once the image is self-information, the low resolution image is interpolated and the high resolution one is obtained. This loses a lot of high frequency data, so you get really bad output. Then there's the prior knowledge scheme, where you have a linear model that describes the relationship between the low resolution and the high resolution one. The drawbacks are that it's highly costly. It has a high computational cost, and it doesn't provide a unique solution. And then you have the machine learning approaches. The modeling base aims to estimate a degradation model or parameter, then between the two images, the low resolution and the high resolution one. The image pair base, where that degradation model is obtained from having pairs of images, low resolution, high resolution, while training. This is the one we're going to focus in. Then the domain translation, and this area appeared because of the need of using real low resolution, high resolution images and not synthetic low resolution images. But there's a lack of them for some domains. So in this case, you have the real low and high resolution, and from one domain, and you use that information along with low resolution images from another domain, which are synthetic in the second case. And then the self-learning base, which takes the most advantage of the low resolution images and doesn't need high resolution ones. And this is a little bit about single image super resolution and the different classes there is. Today we're going to talk about how GANs, Generative Adversarial Networks, are used for this. And so what are GANs? A quick overview, just in case. There are models where you have two neural networks trained in an adversarial paradigm. What does this mean? and which are those networks. You have a generator, which tries to generate images that are as true as possible, as realistic as possible. In this case, the generator will create high resolution images. And then you have a discriminator, which will try to know, okay, is this image true or is it fake? Is it synthetic generated by the generator? So basically you have two networks competing against each other, and the generator will try to deceive the discriminator. The training ends when the discriminator cannot distinguish anymore whether the generator, whether the images are being produced by the generator or not. There's a small diagram where you can see the generator generates synthetic images from latent space, a random latent space, and then you have real images that are compared against each other by the discriminator. A little bit about the methods we're going to compare. The SRGAN, on one hand, it's a convolutional neural networks with residual blocks, which have batch norm, p-ReLU, and convolutions. And then the interesting thing they have is a perceptual loss. The loss is composed by two parts. One, the adversarial loss, where we aim to get as real images as we can, as natural images as we can. And then the contrastive loss, where the super resolution image generated is compared with the high resolution one, and this contrastive loss tries to take care of the noise of the error between the two images. So you not only try to get similar images to the high resolution one, but also real ones that can deceive the discriminator. And then the SE-SRGAN, the enhanced SRGAN, appeared where they did a few enhancements to the SRGAN. Which ones, instead of having just a residual block, they added a residual in dense block, where they also have not only skip connections between the blocks, the residual blocks as before, but also inside the residual blocks, and they also remove batch norm. And so they changed basically the architecture. Then they changed the discriminator also not to just discriminate, okay, this is real or not, but it tries to predict the probability of that image being more realistic than a synthetic image. So it changed a little bit how that discriminator works. And it also has a perceptual loss. That's the same as before. And the SRResNet was the state of the art at the time. And so we use this as a baseline in order to see whether the results were better or worse and how to evaluate them. So the experimental evaluation. We talked about two datasets. One to see how each architecture performed, and one to see the transfer learning capabilities. The one used for the comparing the both nets is the Berkeley segmentation dataset, which has it has 100 images in the testing class. This part was used. It's quite used. It's the most used dataset to assess super resolution, and it has a wide variety. You see wide variety of images. It has people, animals, places, buildings, and nature, and so on. It's quite broad. And then we also have a second dataset of animal faces, which we from Kaggle. You might know the webpage. It has 5,000 images divided in three classes. 5,000 for one class, 5 for another, 5 for another. These are divided in cats, dogs, and wild animals. For training and for validation, it has 500 of each. Only of animal faces. You can see already that this type of images have some certain characteristics, like the hair and whiskers and so on. That will be interesting to see how then the transfer learning capabilities work. And well, then we have to see the metrics. We use peak noise, signal to noise ratio, PS and R, which basically the highest this value is, the least noise we get in our image. And then we have the structural similarity index, which takes into account the illumination, the contrast, and the structure of the image. So this a higher value will prove a better perceptual results. So the results first on using pre-trained networks, one with the weights from the papers for each network on DSD 100 are shown in this table. We can see to start with the absolute values of ESNR and SSIM for each case, and then for the baseline and a really basic method which is nearest neighbor. And the difference between these methods and the SR ResNet are accounted for as a deviation. We can see that both GANs perform really similar to each other and really close to the state of the art, which is the SR ResNet. However, the time used to evaluate the whole dataset is quite different between the different cases. For SR GAN, it's a little bit slower than the state of the art model, but for ESR GAN, it's a lot slower. For these GPUs at the time, maybe this is okay for offline applications, like for online ones. And if we see some of the results in images, maybe here in this, you cannot see it so well, but you can see difference in the droplets and so on, which make the results from the GANs a little more realistic to the human perception. And so on, but you cannot see them at all there. And then the other results, the transfer learning part, we trained SR GAN because it proved really similar results and was a lot faster on the animals dataset, and evaluated the performance both on the animal dataset and also later on the Berkeley dataset to see how it worked. And it proved to have really good transfer learning capabilities, but the results on these metrics for the pre-trained SR GAN were better than the one fine-tuned for the animal dataset. Even though you might see that in some cases in the whiskers and here and so on, in some cases one net to have better results, and in the other cases the other one had better defined hairs and details and so on. And you can see a little bit of the whole of the results on both datasets on that heat map, where we can see that the pre-trained SR GAN is a little bit better. Here are some extra results for different cases. We also tried the animal GAN on the DSD that's animated from the Berkeley dataset, and you can see, for instance, that in the human over there, it looks a little bit fuzzy, which actually makes sense because on the animal GAN, because it makes sense because of the hairs and so on animal faces, which don't apply to that face. So to sum up, well, we assessed different architectures for single image super resolution. We evaluated this on a standard dataset with different weights, and then assessed the transfer learning capabilities of the chosen architecture for another dataset, and got accurate results, but maybe it could be improved a little more. So maybe a little more of research could be done in order to fill in the gap between the GANs used and the current state of the art, and improve those results. That's it. Any questions?
Patricia, for your presentation.
Welcome.
Very interesting. Any question? Okay. Why do you try with GAN architectures? There are other types of architecture for this kind of problem?
Yeah, why we tried GANs?
Yes.
Because the job actually of using this started from a particular assignment that a class that Sergio and Jamal were the teachers, so it actually started there. So, and it was about generative adversarial networks. So that's the reason we started there. and the work was focused on that part.
Okay. The results are promising. I understand. That the results you obtained with this method are promising according to the state of the art.
Yeah, and they are really interesting. It's really close to the state of the art using GANs. And if just an extra part which is in the presentation, for instance, in the paper of SRGAN, they didn't only include those metrics, they also added a mini opinion score, which is basically asking people, how do you feel about these images? We couldn't do that particularly for this case, but in that case, the GANs put better results. The SRGAN, maybe if you compare pixel to pixel, for instance, you might get a better metric, but if you ask me from comparing the results, I think the results from GANs look a lot more realistic. So depending on what you want to apply it for, let's say it's for just an enhanced image for a retail e-commerce website, in that case, a GAN might be better because you don't need to have a site.
Okay. Thank you, Patricia.
Thank you.
Okay, this was the last talk of this session. Thank you very much. Okay, Martin.
At 6 o'clock here, we are going to have a small reception as a welcome for the first day. The program wrongly says open ceremony, but it's a reception. So we invite you to come. Since there's one talk that's missing, we have like 20 minutes of free time, but it will be served in 20 minutes here in the door. And we invite you to come tomorrow to the next day of the conference. Thank you.